Nowadays, the market of used EV batteries is not yet well developed because essentially the newest generation of EVs is not yet arrived at their end of life. However, in a few years, it will be a pretty large market that open the questions whether it's worth going direction of recycling these batteries or using them in a second life application like the ones in power systems. So the DSL will contribute to the project by developing methods that will enable the optimal use of second life batteries in grid applications. We will not only take into account the state of the battery at the beginning of the second life usage, but also how the battery will age along this second life usage and how we will optimally use this information during the operation of the system. At the same time, we're developing sizing methods of these batteries that can be used by utilities and industry players like BKW and Sun2Will. We will proceed in two stages. In the first stage, we will characterize the aging model of the battery by measuring the electrical impedance of the battery by using a technique called electrical impedance spectroscopy. Then, once we will develop a parametric model of the aging, we will use it in order to optimally control the battery, again, in the second life application. And the CSEM is developing not only the hardware, but also the software to do onboard electrical impedance spectroscopy.
At CSEM, we have developed a new system that is capable of monitoring in real time the battery and its state of health in the field. The system gathers additional sensor information and combines suitable data models with smart algorithms. The principle is simple. If the algorithms are the brain of the operation managing the system, then CSEM sensors are the eyes informing the brain about the battery's current state of health. CSEM system is made with cost-effective electronics, and within CircuBAT, we intend to validate the performance of second life batteries in the field.
When a battery is reaching the end of its life into an electrical vehicle, still has 70 or 80% of its capacity. Therefore, it can be used into other applications like those into electrical power grids. This is also allowing to compress the carbon footprint of the battery, since these devices require processes which are quite CO2 intensive.